Okay, this is the continuation of the 2.5 notes. There were some extra examples on U substitution that we needed to talk through. Some of these could be factored, but U substitution is a useful tool for calculus, so it's good to get a handle on it now. In U substitution, we let usually in these quadratics the middle variable be our U, so we will define U as x squared. Then we replace this as 2, there's x to the fourth would be u times another u, so that'd be u squared, minus 10u plus 8 equals 0. We can pull out a 2, so we get u squared minus 5u plus 4 equals 0. This factors into u minus 4 and u minus 1. Solve each part. We get u equals positive 4 and u equals positive 1. But remember, we don't care about the u, we care about the x squared. So we need to back substitute. So x squared equals 4 and x squared equals 1. We need to take the square root of both sides, not forgetting our plus or minus. So we get plus or minus 2 and plus or minus 1. So 4 solutions altogether. For the next one, we would define u as y squared. Go ahead and highlight that. So this would become 3u squared minus 5u plus 1 equals 0. This trinomial is a little bit more difficult to try and factor, but we'll still try. 3 times 1 is 3. Factors of 3 are 1 and 3, and so therefore this doesn't factor because none of that will add up to 5. So we're going to have to use quadratic formula. So u equals negative b, so that'd be positive 5. That's a horrible 5. So positive 5 plus or minus the square root b squared, so that would be 25, minus 4ac all over 2a. This equals 5 plus or minus the square root of, that is 25 minus 12, so that would be 13 all over 6. But here's the problem. This is u. We want y, so we have to actually replace this as now y squared equals 5 plus or minus the square root of 13 over 6. And because this is squared, we need to now take a square root, so this is going to be plus or minus. So y equals plus or minus the square root of 5 plus or minus the square root of 13 over square root of 6. We would want to rationalize that. So multiply the top and bottom by square root of 6. So that would make this y equals plus or minus, that would be 30 plus or minus 6 on the square root of 13. The 6 does not go with that 13 because the 6 and the radical here and the radical here get multiplied together, so this actually makes the 6 distributed as a constant inside here over 6. So notice this one's a pretty messy answer, but this is the correct solution, and there's actually 4 solutions built into this. We did C in class, so let's look at, and I believe we also did D in class. So let's look at maybe E. So U equals T to the 1/2. So that would make this, because this is T to the first, that's 2 1/2s. So that would be 8U squared minus 22U minus 21 equals 0. We would need to do 8 times 21. So 8 times 21 is 168. And it's a negative because it's times a negative 21. Factors. Let's see, does 3 go into it evenly? Yep, 3 and 56. 4 and 42. 5 does not go into it evenly, but 6 should. 6 and 28. And that looks like my pair right there because we want different signs since this is negative and it needs to add to negative 22. So I'm going to go ahead and stop. So then this would be 8u squared, let's put the 6 first, plus 6u minus 28u minus 21 equals 0. Pull out a GCF of each pair. This would be 2u, and that would be 4u plus 3, minus a 7, and that would be 4u plus 3. So after factoring, this one would be 2u minus 7 and 4u plus 3. That gives me a u of 7/2 and a u of negative 3/4. But don't forget, this is not our final answer. We need to set that to this 1/2. Now, and actually I'm going to erase this real quick so I can go back and extend this farther down. So when you plug back in, you're plugging in a t to the 1/2 equals 7/2 and a t to the 1/2 equals negative 3/4. We would try to get rid of these 1/2 powers by squaring both sides, but unfortunately this doesn't even make sense because this actually says the square root of t equals negative 3/4. We don't allow the square root, unless this has a negative sign in front of it, to equal a negative number. So this one actually gives us no solution, but we can square this side. So if we square both sides, that would give us that t is 49/4. And then the last one I did in one class, but I don't believe I did it in the other class. You kind of have to rethink of this one. It looks similar, but there's a 2 kind of messing up the middle term. If you pull that 2 out to the front, then you can see clearly that our u is this fraction of x over x minus 2. So that would be u squared minus 2u minus 15 equals 0. This one factors very easily into a positive 3 and a negative 5. So u equals negative 3 or u equals 5. But we don't care about the u, we care about the x. So we've got to plug back in. So this would be x over x minus 2 equals negative 3, and x over x minus 2 equals 5. I would cross multiply by thinking of those as being over 1. So I get negative 3x plus 6 equals x. And over here I would get 5x minus 10 equals 1x, or just x. Add this over, so this would be 6 equals 4x. Divide by 4, so x would be 3/2. And then on this one, we would subtract the 5 over, so that would be negative 4x. Divide by negative 4, that would be a positive 5/2. And there are 2 solutions for that one. Okay, that's the end of this section.